Welcome back. So that is confidence interval for the sample mean population. Confidence interval for the sample mean. The word to take note here is the what? Is the mean. See, we have two things in the confidence interval. The one for the population and the one for the mean. Alright? But take note here. The population is just once. Then it's like, let's say a scale or a beam balance. The population is just once. We are done with it. Always clear. And when you know that you are dealing with a population, that is, you have to check for the what? The requirement. Right? And what is the requirement? The requirement is that, alright, the requirement is that when you multiply the n by p, and you get it to be greater than or equal to 5, then it means that you are dealing with what? Population. In fact, with the population, proportion. With the proportion, you see it just right in the question. Because the success and the failure will be given to you, and sometimes you will be seeing percentage inside. In fact, you don't worry, I will give you a clue of it. Don't worry. So now what you need here? The mean. So now the mean is also in two ways. It's whether the standard deviation is known. It's whether the population standard deviation is known, or the population standard deviation is not what? Known. So what we are doing here is when this is known. It's when this is what? Known. Alright, so now let's move on. So the random samples still work here. Population standard deviation. So in the question 2, you have to be expecting something like population standard deviation. When you hear a population standard deviation, you know that we are talking of the mean. Alright. And also, good. This is another requirement that you can easily use to get it in this. When the n given you is greater than or equal to 30, is greater than or equal to 30, then, or sometimes you will not see that the n is greater than or equal to 30. You can also hear population is normally what? Distributed. So if it is normally distributed, population is normally distributed. If it's normally distributed, know that your standard deviation is what? Known. Alright. Now, the point estimate here. Now, in the proportion where you use the p hat to be the what? The point estimate. Here, our point estimate is S bar. Is S bar. Is the point estimate for the what? For the mean. So this is the point estimate for the proportion. And here, this is the point estimate for the what? For the mean. Know the difference between the two. They are not the same. And it can never be the same. Alright. The margin error. Now you see, since here, you will not be hearing something like Charles or something like the proportion or something like that. The proportion percentage. Since you will not be hearing certain things, then we cannot let here, if you generate this formula to the other one, we have p hat times q hat here, right? So since this will not come in the question, that is why you have to be expecting population standard deviation in the question, so that will represent this side for you. Please, the formulas are not the same. Make sure you identify it well. Alright, so that is that. Good. So now, this one is going to be our maximum difference between the S bar and the what? And the mean. Yes, the same thing. In the previous one, here is P, here is P hat, here S bar, because this is the point estimate. And the error is that. Good. So let me see what to do. All right. Let me give you the steps. So the first thing to do, the first thing to do is to check requirements. Please, it's very, very necessary. It's not that the person will not tell you that he is talking of proportion or talking of mean. And if it is mean, you only have two things there. Whether the standard deviation is known or unknown. But for now, I'm basing on the known. Alright. So you check for requirements. 2. Critical value. You have to find your critical. You find your critical value Z alpha over 2 for a given critical interval. 3. Find the error, which is Z alpha over 2 over square root of n. Alright. 4. Then you make your confidence what? Interval. That is when you consider S bar minus what? Minus the error. Less than. Here is not going to be proportion, but it's going to be what? Mean. Yeah. S bar plus the what? The error. Alright, so that's what we are going to have. Let me see you for a question. Alright, so beautiful. Let's look at this question. Random sample of 40 students. The average resting heart rate for the sample was 76.3 IBM. It's just a unit or something. Forget it. Assume the population standard deviation is 12.5. Construct a 99% confidence interval for the average resting heart rate of the population. Alright. So what's the first step? Is to check for what? The requirements. So what are the requirements? The first requirement is that there should be a random sample. That one is applied to all, so forget. Do you see something like population standard deviation given in the question? Let's check. Oh, beautiful. Population standard deviation. So the population standard deviation is given in the question. That means that the population standard deviation is known. And once it's known, definitely the n will be greater than 0. Oh, sorry, will be greater than 30. And that is another requirement. That is why we have n here to be what? 40. And the n here is greater than what? 30. Or we can see that. Alright. So we know our population standard deviation to be 12.5. Then, what were we given again? The average resting heart. The average, that's the key word. The average resting heart rate for the sample was 76. Good. So that one too will be the S bar. The S bar, that is the point estimate. That's the point estimate. 76.3. 76.3. And what again do we need? Alright. Let's go for our Z alpha over 2. And here we know that our alpha is going to be what? This one is 0.99. Right? So alpha is going to be 1 minus 0.99. So alpha will be equal to, I don't want to confuse myself, 1 minus 0.99, 0.001. So what you do here is that .75. So when you get this 2.575, then that is when you go and find your margin. Alright, so let's go and find our margin error. So it will be just calculator way. Substitution. So this will be equal to 2.575 times and it's going to be 5.08. Alright, so that will be the margin. Then our confidence interval, sharp, you know this already. 76.3 minus 5.08. If you don't understand anything, where was the previous video? So here is going to be the mean, alright? So you know your x bar is x bar minus the error. So here it is x bar plus the error. And finally you get 71.22 less than the mean, less than 81.33. So that's going to be your last results for that. Alright, now in this case, there are sometimes you can be asked to find a required sample size for a given margin of what? Error. I'll be back with that one also. Alright, so let's see this question. Let's look at this question. Now, first of all, how will you know that the person is talking? It's not that the topic is about me. Let's look at the question. How is it that you see that this is not talking of proportion, but it's talking of what? Me. So you can see that here the question says we want to construct a 95% confidence interval for mean of. So you see the mean there. If it was to be a proportion, it would be a proportion of. So the mean of IQ score. Assume population standard deviation. That one to coming in will let you know it's talking of the mean. Is 15. I want to sample the okay. I want the sample mean to be rating 2 points of the population mean. How big does the sample need to be? So here, how big does the sample need to be? It means that we are looking for the what? The n. Alright. So in calculating for the n, we know that from the formula, before we even come back to make anything, we know that from the formula E is equal to Z alpha over 2 over square root of n. So here you divide both sides by what? By Z alpha over 2. So you get E Z alpha over 2 is equal to this over square root of n. Right? Then you try to make square root of n stand alone. So you get E square root of n is equal to, like you are doing a cross multiplication. Here will be Z alpha over 2. So you divide here by E, divide here by E. So this one will go. So therefore, you will be left with square root of n is equal to that. So you square both sides in order for you to remove the root. Therefore, n will be equal to standard deviation Z alpha over 2. All this over what? E. The whole of this one square. So having this, and you are using this to solve for a question like this. You need to come out with what you are given. So we know that what we are given is that we know our standard deviation for the question is what? 15. That is what is there. And what again? Okay. So you can also see that always, since you are finding for the sample size, the margin error will be given to you. And the margin error, you can see it clearly. I want to sample the mean. I want the sample mean to be written 2 points of the what? Of the population what? Mean. So your error here is going to be 2. Please remember, the error at proportion will be given to you in percent, but at the mean, it will not come in percent. So you don't change to any decimal. Remember. Alright. Okay. What do you need again? You need to identify Z alpha over 2. And this is what? 95% what? 95%. That is 0.05. And you know that that one too will be 1.92. Alright, then what again? That's all. So N will be equal to standard deviation of 15 times 1.92. All this over E. The E is what? 2. All squared. Don't forget the all squared. And when you do that, by calculator, you get 216.09. This is what you have on calculator, but you have to run what? Up. So when you run up, you get 217. Alright. The reason why we are running up is that here you cannot, this N is a number of people, and we cannot get somebody to be a decimal. Can we get that? Or it's you? No, you can't be a decimal. You are precious to me. Okay. Alright. So that's what we are going to have. So our next video, we are going to look at how we can get this margin error or the confidence interval when the standard deviation, we are still at the mean, but this is when standard deviation is known. So what if when standard deviation is not known? Remember, get ready for T distribution. Bye bye.